everyone, welcome to the second Tools in Action I have here at DevOps UK, the Automation Challenge Kubernetes Operators versus Helm charts. It's going to be a little race today. So, first of all, I'm Anna. Happy to be here today with you in person and to share a little bit more about Helm charts and operators. I love to solve some complex, challenging technical scenarios sometimes that involve Java-based frameworks and Kubernetes. Kubernetes is a love that I have found some years ago, and I still enjoy developing with it, besides Java. I'm a Java champion starting this year, and I've also have certified myself as an architect also this year. So quite a full 2021 for myself. And I hope that you'll enjoy my talk. First of all, why this talk? Because nowadays microservices are kind of associated with Kubernetes. Because this divided emperor architecture of microservices is kind of going with Kubernetes, because Kubernetes is kind of empowering its features. Kubernetes is there to help you with the independent deployment, is there to help you with the fault tolerance, is there to help you, with the fault isolation, is there to help you with the zero downtime, especially with zero downtime, and it's there to auto-scale things for you. So it looks like it solves all the infrastructure problems that are there, that could be there for your microservices. And to give you an example, these are the features that people are looking into when they're choosing Kubernetes. It does automated rollouts and rollbacks. It has self-healing. This sounds very powerful. It has horizontal scaling. It does a lot of things automated. It barely, you can say it even cooks for you, like not just doing all these things and much more. So this is why people choose Kubernetes and going ahead with the microservices platform. However, when going down the road, to add Kubernetes to what you're doing as a developer, of course, like always, the story of a microservice starts simple, with your application code. We are happy, coding in your favorite language. And then you're adding a Docker file. And then you need to, run this Docker image in a container somewhere, and you need some definitions on how to do that, and there's some environment configuration. So you start writing YAMLs, so Kubernetes objects in YAML format. And you write one, maybe two, because, well, maybe there are some other objects that you want to keep in your YAML files that help the configuration of your microservice. And like a good developer, you just want to split things across some YAML files. And then you start asking your question when you are moving that microservice to another namespace. Because, well, it has to go through multiple namespaces until it reaches production. You have to test it, you have to integrate it, and do some integration testing, some load testing, and a lot of other testing to make sure that's resilient. So, and you start noticing that you're adding a lot of YAMLs when you're kind of trying to multiply the same action of deploying your application. But your application code doesn't change, your Docker file is still the same, but you keep adding of these YAMLs, right? And you kind of ask yourself, like, how many times would I be doing this thing, writing so many YAMLs? And it becomes like a burden to maintain all these YAMLs hard-coded and to do all the changes for your app in all the namespaces and keep so many together just for a single app. And then think about a distributed system. It has more than one microservice, at least in theory. And if you have to do it for more than one, and of course, it depends, of course, the size of your team. But it kind of is burdened. It's not very streamlined, right? So this is where Helm is kicking in. Because Helm, the Kubernetes package manager, is there to help you with templates and, of course, with some parameters to manage and update multiple Kubernetes configurations, to do this deployment of many configs as a single application. So when you are installing your app with Helm, you're actually seeing one installment. You're not doing many more things sequentially. You see it as a one thing. It's a one release happening there. And you can also parameterize for multiple environment support. So there's no need for the multiple YAMLs where you have like hard-coded values, and maybe you forget one, who knows, and it's very hard to maintain that. So this is quite cool about Helm, right? Let me show you that, because this is a tools in action session, and I need to show you things. For the tools in action of today, okay, here. Let me make this bigger. Okay. I have 3 microservices. So we're going to deploy an event, a landmark microservice, and a ticket store. The idea behind it is that we're having a ticket store that sells tickets to different events or to different landmarks. It's a very basic app and UI. Please do not judge the UI. And first of all, we need to deploy the so-called backend. And let's do the event deployment. And for the event deployment, I will use Helm charts. And this event microservice, it's persisting its data. It's a Quarkus app, and it's persisting its data in a PostgreSQL database. So if I'm just going and following the README, because I have some installation here, just going like this and copy-pasting this into my terminal and installing the database, right? Read, easy peasy and neat. And I hope that the internet is going fine. Let me clear this. Okay. And Helm status. Okay, event. Forgot this one. And just get the kubectl get deployments for the actual kubectl get pods. That's the real thing. Okay, it's running. Cool. So I deployed my database with one command with Helm. This is pretty cool because I can use community charts or charts that are already done by vendors, and I can install my stuff. Now let's do the trickier part. Describe this microservice with a Helm chart, right? So for doing that, I need to go to its location, cd event, I have chart here. Nothing in it. Let's create the chart. Normally you would do this, Helm create, and say event. But we're 30 minutes, and I'm going to cheat a bit. And one thing that you can do with Helm is use starters. So for example, if you had like a good pack of starters when you were like using your app, you can propagate those good starters and reuse them across your Helm charts. And this works in your local really nice. So I'm using such a starter here. I'm going to use Helm create event from the starter event. And hopefully this is doing some good stuff for me. Let me check how the chart is going on. So it generated some things from my starter. I love the starter because it also has some validation. It's things that I've worked before and I trust it, right? So I need to do some changes. First of all, let me look at the image here. It says Umbra event tags 201. Let me check if I have it. Event. Okay. Tags. Oh, there's 201. So it's at least up to date. I used to have some older versions as well. If not present, container port, I think it's 1990. Let me check the configuration here. Oh yeah, 1990. Okay. And, well, I need to connect it to my database, right? So I could use the PostgreSQL definition and just give these details for my event database, the one I created earlier. So I'm using the Postgres database, the event default, the secret name, and the secret key. And I'm injecting this automatically to my Helm chart. I have everything defined because I've used this model before and I trust it with its configuration. So if you write a good YAML, why not reuse it? Especially with Helm. And let's go and install it and see how easy it is to work with it. So Helm install simple from, okay, event. And let's install it. Hopefully nothing is going to be wrong with it. Helm status simple. Okay, looks deployed. And let's just get the pods part. Okay, event, simple event is running. Okay, simple event is running, which is good. We have one deployed microservice that's using a database that's also been deployed with Helm, which is quite great. Now, next level, maybe you want to do this like 2-in-1. Don't wait for, make it separate installation. Like do it 2-in-1 with the leader chart approach. So that's what we're going to do with the leader here from the landmark. So we're going to deploy the landmark from the leader chart approach. And I need the landmark. Okay, so I'm going to clear it here, go to the landmark, location and go to leader. Now this landmark is going to be a subchart. So I'm going to use the charts folder and instantiate it as well, like Helm create landmark. Also from a starter, if I have it, hopefully. And hoping that is generating fine. Yeah, I have some schema defined here and everything works like a charm. But I also need to, make some changes because right now, I don't care about these because I'm going to start 2-in-1. So this one looks after the global variables of Helm. Doesn't look for my local ones in the chart. Then I need to specify that you have to install this Helm, you need to install this 2-in-1. So you need to do the configuration globally here. Let me see if I can rearrange this. Hoping that this is not going to affect. And just deploying this one here with the PostgreSQL configuration. So this one is going to be globally defined and afterwards reused at the level of landmark. And one more thing, I need to specify that, well, this is a published chart, and I'm going to chart.yaml. And there's a place here that says, these is the dependencies needed by the leader chart. Each time you need a new dependency, add it to this area. So this is what I'm going to do. I'm going to add my new dependency here and hope that this is going to do a good installation of my microservice. So go to cd, helm install leader from leader. I have an error. Important execution, blah, 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 executing. I don't need the HPA for the moment. I'm going to delete this one. I don't. Yes. Helm status leader. And get the kubectl get pods and see how things are going. So the simplest event is running. The leader landmark is not yet running. Oh, alien landmark is running. So pretty much easy to use the Helm charts with the deployment, right? True. The thing is that Helm comes with some advantages. You can easily prototype an application installation. You've seen that. 2 ways to do that. You can separate the non-final values from the actual objects in the values.yaml pod. And you can deploy many configurations as one. So you see the release, when I'm using Helm status for that release, I'm seeing that as a one thing, as a one app. Like I was supposed to see my microservice, one app, one deployment, one entity. And then I can check in a template and use nested values and use checks at the level of a template. And if you're I'm going to share the repo with you. If you're going to go to the repo, you're going to see that I've added some extra checks and I've played a little bit with the Go definitions there so that I can make it and enforce it to be as error-prone as possible. But there are some distinctive Helm aspects that I want to draw attention to. So Helm can help you more than what I did, like installing the app. You can automatically roll deployments using annotations. So you can do this by the roll me annotation there, and you can automatically do that. Then what Helm is doing is encouraging to reuse things with include, with helpers _templates.tpl, and defining more templates at Go level, which is really great. And then you can instruct Helm to keep things upon uninstall. Maybe some resources are not going to change upon your uninstall or when you are trying to correct something. You don't need to go and destroy everything every time when you're uninstalling something. You maybe want to keep some resources there. So let's keep it. Also with annotations. Now, next step on this thing is that we're looking at the 2 microservices that we have right now. We can scale them independently, which is quite great. But what I notice right now is that I have 2 databases. Each microservice has a database, and I'm maintaining it via Helm. And I'm thinking how I'm going to maintain a database with Helm. How is that going to be easy for me as a developer? The reason being is that when when you're doing this with Helm, you're like starting to think like, how many times will I be doing this and taking care about databases and how many namespaces? How am I going to upgrade them in so many namespaces? It becomes like a little burden again, right? So what happens at the maturity of your system? Like, how do you do when you have still these more things to manage? You've done it with Helm. Helm has solved some issues for you, but you still got into other problems like, how do I maintain those stateful sets of PostgreSQL? And that's when operators kick in, because operators are there to package human operational knowledge for you. So they are there to do automatic stuff that you would have done manually to maintain those stateful sets. Helm is working good with stateful sets, but operators do it better. And one other thing about operators, they work very well with kubectl and dashboard. You can write them in many programming languages, even in Java, for example. And they can be used to create backups for configuring your clusters. So there are operators there available so that you can do the backups. If you ever try to do a backup the hard way of a Kubernetes, you know that there's a lot of etcd commands you need to back up etcd, and it's not very nice, and you have to remember a lot of stuff. And imagine if you're like having an etcd cluster, so that's even nicer to do manually. So this is where operators help you, especially as an admin. You can administrate Kubernetes easier. And then you can use cloud native, you can see that the cloud native tools can be maintained via operators. From my experience, I'm using an OpenShift. I'm installing Knative from operators. I'm installing Istio from operators. I'm installing Kafka with Streamz from operators. I'm not using anymore Helm, or I don't want to do it manually anymore. I just do some clicks, and things are installed and maintained. And you can also upgrade them really, really easy. The thing is that, what's next for our scenario with the two microservices? So for one of them, the one that has the Helm chart separate for the PostgreSQL database, I want to replace that one with an operator. So what I did, I inspected the operator hub.io. I decided that I want to use a Postgres operator because there are actually multiple operators there. I deployed it. And then I was able to install, or maybe reinstall that chart with Helm install, or I'm going to upgrade it in a minute, and maintain the PostgreSQL databases via the operator. It's easier for me because it's easier to upgrade an operator that automatically manages everything related to Postgres, including the stateful sets. So before going and creating an operator, let's replace things and go back here and say clear and go to event and replace event details in the values.yaml. So this node is not going to be my installation anymore for Postgres, and it's going to be this one from my operator. If you're wondering where I get those, kubectl get secret. This is the secret of the operator. I know it's a lot of info, but is this one here. It's containing my PostgreSQL database. The secret key is password. The database is the same. The username is the same. The server is pretty different because I need to give us a different server name for the service, so that's not a difference there. And now, all I need to do when I change this to maintain my event, Helm upgrade event, no, simple, from chart. Okay. Chart.yaml is missing. Am I missing something here? No. Ah, forgot something. Chart event, because that's where my installation is. Now let's check the status. Okay, it says revision 2, so now my application, it's revision 2, is deployed. It's pretty good. And see Helm simple. And Helm started simple is okay, clear. I can get all the information about my prepare for something very long and scary. Helm get all simple, and this is going to give you a lot of YAML, but this is going to give you information about everything you deployed and everything that's available there in terms of Kubernetes objects. But if you just want to check how things are for your installation, just say kubectl get pods, and everything has been running and is okay. Cool. So this is the backend part of our deployment, and it was easy to swap it. You can see even though that I installed the Postgres operator through two different means, the different commands, from the Helm chart perspective is the same thing. It needs just a PostgreSQL database somewhere. How about creating an operator? There are some options available to create your own operator there. So if you like to be very, very agnostic from the programming language, you can use Kudo, KubeBuilder, MetaController, or Operator Framework. I personally love this one, the Operator Framework. And I've used this one to create my own operator for the front end. And the reason being is because I want to be able to access my ticket store from the browser to consume the microservices from one single location. This one, although you see here it says Helm, it's actually installed via an operator using the Helm plugin, which is pretty cool. I did a small mistake. Okay, sorry for the trouble. If I'm keeping an escape is going to be trolling. Now, how to evolve from Helm charts to operators? First of all, what I did, I published my Helm chart to repo. And you can use GitHub as your Helm charts repository. So what I did, just simply I packaged my charts because I started to do Helm charts for the front end as well. Then I simply added Helm repo index to say that, hey, you should know this is going to be my repo where you're going to find these chart, and you should be indexing about that. And then I just did some simple comments for Git to add my charts, my published charts, and to be seen as published. Next level, create an operator from Helm charts. So I added my published repo, my publicly available published repo, to my local repo. And its name is store in my local repo. Then I created my operator folder. That's not very interesting. And I was able to init it via the Helm plugin. So I just said, hey, just magically do for me an operator starting from these Helm charts and do it using the Helm plugin chart and just generate for me stuff. And last but not least, if I want to install my front end, I'm going to use this command, kubectl apply, and I'm going to install a sample of my front end. So if I'm going back to the IDE level and go to front end, let me go here, ticket store, clear. First of all, my operator, which is magically in the ticket store, clear, the operator. I need to make it and run it. So this one is going to install locally in my local minikube, the operator, so make install run. And it's going to install it automatically for me. And I hope it works. Sometimes I don't know, it's failing. Could not find resource, could not find resource. Why? Might have issues with the internet, we'll see. Otherwise, I'm going to do it again. Recreate it with the commands that I show. And let's apply and install it. So kubectl apply -f from the samples. This operator, okay, operator, config, samples, chart something, and install it. Could not find the requested resource. Clear. Let me do it again. Start. Please work. And I think it's working. Let's try it again. Now it's created. I was about to. I'm like, oh, it's not working. And let me just try it in the browser. So I'm going to get my minikube IP and go here. See how my ticket store is looking like. And so I need the service, which is this one running. kubectl, actually, kubectl get service. Because what the operator did, it spin up an entire deployment for me for my ticket store app. And this one is running on 3.1.3.1.30, blah, blah, blah. Let's kick it. Okay, so I got some data here. So this is my final view of my app. Installed, the latest part installed with operators. It does some things. Oh yeah, and it didn't connect to the landmarks part. It just got them there now. There are some things you can do. You can filter things. You can get information about stuff. You can get all of the stuff here. You can get all. And it's just some basic operation in it. But it's showcasing how things are working together with operators in Helm and how you can magically install things. But not only this, let me go back here, clear, minikube, clear, minikube dashboard, minus URL. Okay, hope I got it right. The thing is that if I would go now and do this, if I would do this with Helm, there would be probably not much happening except for that automated deployment things going on. So now I'm deleting a deployment. But thanks to the operator, things are spinning up again. So the operator is there to maintain things alive, even for objects that are not automatically spinned up to life by Kubernetes, because operators are instructing Kubernetes and talking to Kubernetes and about the higher maintenance of all your app. So this is the goodness of operators and Helm charts. And some takeaways for you is that for Helm, it's good to have a custom, they have a good custom packaging format that you can deploy a generic application and you can be happy with its settings. I would recommend going with Helm for stateless apps mostly. Or if you want, like, it's great for checking the application deployment. They have annotations that can trigger automatic deployments. But if you're having needs to install applications that are stateful, and you need to maintain stateful sets and other kind of Kubernetes objects, like a whole thing, try to go with operators. Because they are the way to operate at the bigger level, even Helm charts. So you can see they work really well with Helm charts. So if you want to add more automation to what you already had with Helm, go for operators. And as I said, they're useful for operations regarding backups or cluster configuration. For example, in OpenShift, if you want like a backup or things, the entire backup configuration part is using an operator as well. And I want to thank you for listening to me. If you have any questions, please address them to me or via the platform. If you scan the QR code, the presentation is there, and you can find again the URL to my code. There is more to it. All my charts are having validations via the JSON schema, because I like for things to get validated and not just go ahead with things and trust things. Because you can make mistakes also with the with the parameters. How do you know that a colleague has put the right parameters there? You can enforce that with JSON schemas. Yes, I think a little bit more about annotations is present there in the repo. So do check it out and do try it on your own. It works on your local machine, so you don't need to have a fancy configuration to install it. It doesn't consume that much. And yeah, have fun with it. And if you find any issues, please raise raise an issue to me, and I'll try to figure it out and check it out. Thank you for listening to me, and I'm welcoming questions from the audience, if any. And shout the question, please, because it's very difficult without a microphone. Please shout. Can you come closer? I'm sorry. Or shout it. Okay. So the GitOps methodology, working together with Helm and probably with operators, well, they do work very, very well with. I know that Argo is working very well with operators and with Helm. So I've seen some things done by my colleagues with Argo, and they're really cool and more advanced for me. I'm just beginning with Argo, by the way. So from my point of view, if you want to add even more automation, you can definitely add on this something like Argo or Go to with Tecton on top of these things. So also for the operators part, I want to mention that there's an Ansible plugin. So if you want to reuse some of your Ansible configurations for automating that, you don't need Helm necessarily. You can also put the plugin for Ansible and do those automatic deployments also via the Ansible plugin as well. So there are multiple ways to maintain things via the operators if you want to, but it definitely works when you want to scale and maintain things at a higher level with Argo or with Tecton and with their pipelines. Thank you. Any other question? Time's up, but if anybody else has another question. If you have more questions or you remember something, please come to the Red Hat booth. You're going to find me there, and I'm answering to your questions regarding the operators or Helm or anything you have in your mind, or feedback, of course. Feedback is always welcomed. Thanks. Enjoy the rest of the conference.